Hello, everyone. My name is Tim Chou, and this is one of five different presentations that talk about core technologies that I believe could change and transform businesses, industries, and countries. In this one, we're going to talk about AI, artificial intelligence, which I'm sure all of you have heard this word. I'm going to try to be a little bit more precise about what we mean by this. I think a lot of times these days, as we do in tech, everything that looks like magic, we just call it AI. And I'm going to try to help you understand that there are some technologies here that actually are transformative. I think in the world of AI, we're all seeing examples of this. You know, you your Alexa, or Google, et cetera. Everybody's got various forms of language recognition systems out there, which, frankly, work dramatically better than anybody expected. Although I think, as many people realize, there are challenges in this space because, when you're talking about the wide domain of what people can say, and many of you have seen this, Alexa won't answer every question that you have and can't respond and doesn't understand. But I think it's demonstrating what the potentials are of this technology. One of the areas that I think has changed in a dramatic way is language translation. Once upon a time, I think it was pretty primitive, but today the ability to get translation and people are working on near real-time translation as well has been dramatically improved from where we were, I'll say even 5 years ago. Just to give you a sense of how rapidly things have changed, I want to show this chart. This is there's a competition which many of you probably never heard of because they stopped doing it about 5 years ago. It's called ImageNet. The ImageNet was to be able to see if computers could recognize images better than humans. In 2011, they started this challenge. And as you can see on this chart, humans recognize images, basically 95% of the time. And in the case of, in the 2011 example, computers can only get to 75% of the time accurately recognizing what that image was. As you see here, every year, improve. By 2015, actually, the computers were better than the humans. And that's why you probably never heard of this competition, because there's no reason to run it anymore because the computers are outpacing the people. The question you might ask is, well, what's going on here? Why is this happening? And this is a chart I shared in the section on the Internet of Things. This is courtesy Jeff Dean, who heads up Google's AI efforts. And I think it's really a useful way to think about this. Basically, neural networking technology versus any other, quote, approach has been able to show dramatically increasing accuracy, as you just saw. The more compute you throw at it, the more storage, the more data you have. And as we talked about in the world of cloud computing, this is starting to happen. Just a quick, so you know what a neural network is. And there are, I'm scratching the surface here, but this is a way for you to think about it. Basically, it tries to emulate how many people think that the human brain looks, which is neurons which fire based on the inputs to that neuron. So in essence, each one of these nodes in the neural network have data coming into them, a weighting function, and then what is called an activation function, meaning whether I fire or not. The input layers are, you could think of it as I'm showing up here, speech, it could be image, pixels, etc. There are a group of what are called hidden layers. So this, you'll hear people talk about, 32 layer convolutional neural networks. This is what a layer means, multiple layers. that ultimately result in a output layer, which, is, oh, I recognize that you said the word hello world. So neural nets there are a variety of different kinds of them, many different experiments about which kinds work in which situations, but fundamentally, that's what a neural network does. So neural network technologies take advantage of being able to use large amounts of data and large amounts of compute to train these networks on, as we just talked about, recognizing an image. I mentioned, or I talked about in the section on the lectures on cloud computing, that one of the huge advantages that has happened in terms of the cloud is a very different business model, which allows me to throw a ton of compute for short periods of time. So in the phase where I am trying to learn on this data, I don't need to run 4,000 computers for a month or a year. I run it for an hour or two, determine whether or not I have to change the weighting functions, et cetera, and then I go try it again. So this model of being able to put a lot of computers to work for not a lot of money on an OpEx basis is enormously beneficial for this model, as well as obviously the ability to store a lot of data. As we indicated, the higher quality of accuracy is also determined by being able to throw a lot of data at it. One of the points I'm going to talk a little about what are the things you ought to think about as you think about the world of AI. One of the things to make a point of is the development of AI algorithms does not follow the same life cycle as conventional software development. Conventional software development has always been what I call precise, meaning, oh, I want to transfer, money from savings to checking. Well, it should work the same way every time. I mean, you wouldn't want it any other way. So it is about developing precise workflows in general. Whereas in the world of AI and machine learning, it is not always precise. I'm going to show you a quick example of what a ROC curve is, but you've all heard the word false positive and false negative, but just to think about it, you're not going to be 100% correct that stop sign is a stop sign or whatever, but you don't want to have too many false negatives in order to do that. So it's not going to be deterministic, and so the development life cycles are very different than what we see in the world of conventional software development. I'm going to spend time talking a little bit more about what people will call supervised learning. So supervised learning meaning I am training based on knowing the quote correct answer and trying to train the algorithms to get to that right answer. One of the challenges you have to doing this is you have to be able to label the data. So you have to be able to determine, as we're showing here, whether it's a person or an object, whether it's a stop sign or a yield sign, et cetera. So being able to accurately label data is terrifically important to being able to run good supervised learning algorithms. This is a challenge because obviously in the world of the automobile, maybe I can get humans, regular people, to label the data. But as soon as you move over to like medical imaging and whatnot, obviously not every one of us can recognize, pneumonia in a CT scan. And so labeling data is a challenge. People are working on how to speed up labeling, how to augment labeling, but labeling is a challenge. Once I get labeled data, then that becomes part of my training data set. I will split into a test data set and a training data set. So obviously I'm doing dogs and cats here, where I will progressively change the weighting functions. I may change the feedback loops. I may change the number of layers, et cetera, to more and more improve the performance against the training data set. Ultimately, I will then take the other data set, the other half, and plow it through here to determine whether or not I am getting accurate results. I'll show you some examples in a minute. Uh, Obviously, I want to be able, in my example here, to be able to determine it's a dog and not a cat. Once I have built that training, once I've built the weighting functions, the last step is I implement this in what is referred to as an inference engine. These can be very low in compute requirements, but once I've developed the neural net, the way I implement it is through an inference engine, which in our example will accurately reflect that, yes, that indeed is a dog. We're seeing this technology arrive in lots of different ways. Netflix, great example of, obviously trying to predict what movie you want to watch or what movies would be good for you is terrifically important to their business model. So a lot of AI technologies have been applied here. In the world of financial services, fraud detection is an interesting problem to solve. Obviously, I don't want too many false positives, because if I decline this credit card too many times and you're a customer, you go, Christ, I'm going to go somewhere else. Obviously, if I get too high a false negative rate, meaning I miss these, then I'm going to be subject to a bunch of fraud and lose money that way. This is just showing an experiment that was run. Conventional rules engines are very static. Classic machine learning is showing you the performance. This is I'm not going to go into describing a rock curve, but this is what's called a rock curve. I encourage you, if you're interested, to go study this. This is the way you measure the effectivity of a machine learning and AI algorithm. And obviously what this is showing you is that deep learning networks were able to achieve much better performance than either classic machine learning or rules engines. This is just an example out of the world of agriculture. This is actually a multi-layer neural network that was built in Korea. Turns out the radish industry in Korea is an important industry. There is a particular kind of blight that can happen in the field. And so what they're using here is image recognition to be able to determine what areas there might be blight in, and therefore, go in and treat the plants, et cetera. So this is an interesting example out of the world of ag. And then obviously I've been using some examples out of the world of healthcare. It's a very famous piece of work that was done at Stanford called ChecksNet to be able to do pneumonia diagnostics. And obviously what you're seeing here is demonstrations that the computers actually had higher performance than the doctors did in terms of the accuracy of diagnosing that this was pneumonia. In the end, whether we're talking about medicine or agriculture, whatever, most of our efforts in the software world have been devoted to workflow, meaning the sequential steps of activities to accomplish something like buying something in the shopping cart. But as the Amazon.com website shows you, the transactional system, the workflow system, is starting to fade. In fact, it has completely faded in the background. And in exchange, we're seeing analytics and artificial intelligence be able to provide more customized information, more accurate information to us. So with that, hopefully it gave you a brief understanding of what AI, and particularly I've talked a lot about neural networks, are, why the improvement in performance of these systems, and a little bit of a glimpse as to how it can be applied in multiple industries. Thank you very much.